something is happening on Mars. Not a theory, not a simulation, a real signal picked up by a real rover sitting in the dust of a planet we thought we understood. And right now, NASA's top scientists are still arguing about what it means. For decades, Mars has been the most studied planet outside our own. We've sent rovers across its canyons, drones through its thin air, and satellites into its orbit. We've mapped its surface down to the meter. And yet, in the last few years, Mars has started doing something it isn't supposed to do. Strange gases appear in the atmosphere, then vanish without explanation. Rocks show patterns that look almost organic, and signals from the surface keep showing up in places and at times that don't fit any model we have. This isn't science fiction. This is happening inside real data from real missions right now. And the closer scientists look, the stranger it gets. Let's start with the methane. Mars has almost no atmosphere to speak of, just a thin wisp of mostly carbon dioxide. But buried inside that thin air, NASA's Curiosity rover has repeatedly detected something it shouldn't: spikes of methane gas. On Earth, methane is almost always a sign of biological activity. Cows produce it, bacteria produce it, decomposing matter produces it. It can also come from geological processes, but those usually leave other chemical fingerprints behind. Fingerprints that, so far, haven't matched what we're seeing on Mars. Here's where it gets strange. The methane doesn't behave consistently. It spikes at certain times in certain seasons, then disappears almost completely, only to return later. Scientists have ruled out simple explanations like instrument error, dust storms, or seasonal warming alone. None of them fully account for the pattern. So the question becomes uncomfortable. What is producing gas that appears and disappears like something alive? The methane mystery isn't happening alone. In 2024, NASA's Perseverance rover, exploring an ancient river channel called Neretva Vallis, drilled into a rock formation scientists nicknamed Cheyava Falls. What they found stopped the mission team in their tracks. The rock contained leopard print-like spots, dark rings with bright centers, caused by chemical reactions involving iron, phosphate, and organic carbon. On Earth, almost identical patterns form when microbes interact with rock in low oxygen environments. It's one of the strongest potential biosignatures ever found on Mars, and NASA was careful to say it is not confirmed proof of life, but they were equally careful to say they couldn't rule it out. Then there are the Recurring Slope Lineae, or RSL, dark streaks that appear on Martian slopes during the planet's warmer months and fade away in colder ones. For years, scientists debated whether these were caused by flowing salty water, brine that could remain liquid even in Mars's brutal cold. Newer data suggest dry granular flows might explain some of them, but not all. Some RSL behave in ways dry sand simply doesn't. And then there's the atmosphere itself. Trace amounts of oxygen have been measured rising and falling in ways that don't match known chemistry. Like the methane, it spikes, drops, and refuses to follow a clean, predictable pattern. Individually, each of these anomalies could have a mundane explanation. Together, they form a pattern scientists can't fully close the loop on. A few things make this even stranger. Mars's gravity is only about 38% of Earth's, which means gases can escape into space far more easily than they do here. If methane is being destroyed that quickly, something equally efficient must be replacing it just as fast on a regular cycle. The Cheyava Falls rock was found in a region geologists believe held a river system billions of years ago, meaning if life ever existed there, this is exactly where evidence should survive. And perhaps the most unsettling detail, the same methane spike pattern detected by Curiosity on the ground was also picked up years earlier by the European-Russian Trace Gas Orbiter from space, but at different times and locations. Two separate instruments, two separate agencies, both seeing something real, but not yet seeing the same thing in the same place at the same time. That mismatch alone has kept atmospheric scientists debating for years. This isn't just about curiosity. If Mars truly has an active source of methane, biological or geological, it would mean the planet isn't the dead, frozen world we once assumed. It would mean Mars might still be chemically and possibly biologically active beneath its surface today. And if it turns out to be life, even microbial life, it would be one of the most significant discoveries in human history. It would mean life isn't a one-time accident that happened only on Earth. It would mean the universe might be far more alive than we ever dared to believe. That's why NASA is moving cautiously. No agency wants to make a claim this big without being absolutely certain. But the data keeps pointing towards something real and something we don't yet fully understand. Mars has kept its secrets for billions of years, but cracks are starting to show. Gas that shouldn't exist, rocks that mimic biology, streaks that defy easy explanation. We may not have the final answer yet, but for the first time in human history, we have rovers on the ground, instruments in orbit, and missions already being planned to dig deeper, literally, into the question that has haunted us since we first looked up at that red point of light in the night sky. Are we alone? If you want to keep exploring the mysteries our universe still hasn't answered, subscribe and stay with us for what we uncover next.